Hello students. In our previous presentations, we have seen many aspects of sliding contact bearings. In this presentation, we intend to study about various bearing materials, what are various bearing failures, what are their causes, and what are the remedies. So the objective of today's presentation is to know about the desirable properties of bearing materials, know-how of common bearing materials, then what are the properties that a lubricating oil should possess, then what are the common failures in sliding contact bearing, and then what are the causes and likely remedies of various failures in sliding contact bearing. To begin with, let's discuss first of all what are the desirable properties of a good bearing material. As we know that during operation there is chances that the temperature may become high. So a bearing material should have anti-stick property so that it should not weld to the general surface when temperature becomes too high or when there is metal to metal contact. Secondly, they are supposed to take large radial loads. So to support that, they should have high compressive strength, they should have high fatigue strength, they should possess one property which is known as conformability, which is the property to adapt to the shape of journal. Because if it is not there, then the distortion will take place. There is another property which is called as embeddability, which is the property to accommodate dirt particles likely to be present in the lubricating oil. The bearing material should have good bondability. What do we mean by this property? Most of the bearing materials will discuss in the next slides. They come in the form of strips. They are stick to the steel shell. So if the bearing material is having property of bondability, that means it will bond well with the high strain steel shell. Otherwise, it will wipe out. It is possible that there may be some corrosive uh, substances present in the lubricating oil. So our bearing material should have sufficient corrosion resistance. Our bearing is supposed to dissipate large amount of heat, so it should have high thermal conductivity and low thermal expansion. It should have very low friction coefficient so that heat generated is within limits, and obviously it should be of reasonable cost and easily available in the market. So these were for a few properties that a bearing material should possess. Now let us discuss about bearing materials and the properties they are having. The most common bearing material are called babbets or white alloys. They are basically alloys of antimony and tin with few traces of copper. They are widely used as a bearing material. The pluses are they have excellent conformability and embeddability, the properties that we have discussed in previous slides. But the drawbacks are they tend to lose their strength quite rapidly at higher temperature, and they have relatively very low fatigue strength. Second most preferred material after babbets are bronzes. They have excellent casting and machining properties, but they tend to stick to the general surface at high temperature. Then comes copper lead alloys, which are more hard and having high fatigue strength, and they are used in heavy duty applications. I would like to point out over here that babbits and coppelet alloys, they are used as strips. 0.5 mm thick strips are available. They are bonded to the high strength steel shells and used as bearing material. Another materials that are commonly used as bearing material are aluminum alloys, silver, graphite for high temperature applications, Teflon, which is used when it is not possible to supply lubricant, because with Teflon no lubricant is required as its friction coefficient is very low, and rubber bearings are used in marine applications. So we have seen that plenty of materials are used for bearing materials as bearing materials. They are having few advantages and few disadvantages. Let us discuss the most common lubricant used in the bearing, which is oil, maybe vegetable oil or mineral oil. What properties a lubricating oil should possess? First, it should be available in wide range of viscosities. As we have seen in our previous class, we find viscosity of lubricating oil using Sommerfeld number that will depend upon the RPM of the application and bearing pressure. So it is likely that the viscosity might come in wide range. So a lubricating oil should have viscosity in a wide range. It is always desirable that viscosity should not vary much with the temperature. It should be chemically stable. It should not react with the bearing material. It should have sufficient heat, specific heat. Then only it will be able to dissipate the heat from the bearing surface and should be commercially available at reasonable cost. Moving further, let's discuss common failures in sliding coordinate bearing. There are four types of failure commonly observed. They are abrasive failure, wiping of bearing surface, corrosive failure, and failure due to distortion. In the next slides, we'll see their causes and what are the possible remedies. First failure which is observed, it is called as abrasive failure. What happens whenever a particle is embedded between journal and bearing? If the bearing is too soft, it often put some scratch marks on the bearing. You can see this over here. It occurs when there are foreign particles or rust particles present in the lubricating oil, or you can say when lubricating oil is not clean. We can avoid this type of failure with proper enclosure, cleaning the housing of the bearing at regular intervals, using high viscosity oil, etc. Next failure, which is very common, is wiping of bearing surface. We have seen in the bearing materials that often bearing materials are used as a layer, 0.5 mm thick layer. So you can see over here that the layer has been wiped out. This failure is called as failure due to wiping of bearing surface. The reasons can be excessive rubbing of journal. It can be in the form of surface melting and flowing of bearing material. Uh, that can be due to inadequate clearance, excessive load, and insufficient oil supply. If we keep these factors under control, which is providing sufficient clearance, operating the bearing with design load, and supplying oil sufficiently uh, all the time, we can avoid this type of bearing failure. Next failure is corrosive failure. You can see over here that on the bearing surface corrosion has taken place. It is caused by chemical attacks of reactive agents which are present in the lubricating oil. Oxidation products corrode materials such as lead, copper, cadmium and zinc. Causes are again inadequate clearance, excessive load and insufficient oil supply. If we keep these factors under control, we can avoid this type of failure. Next failure is distortion failure. When there is no proper fit between journal and bearing, this type of failure might be there. So it is caused by misalignment and improper fit. When fit is too tight, the bore distorts, or we can say when foreign particles are trapped between the bearing and they are too hard, then the housing during the assembly, then local bore distortion occurs. The failure can be avoided by correct selection of fit and adopting proper assembly procedure. So in this presentation and in the previous presentations, we have tried to cover various relevant aspects of sliding coated bearing. We started with the modes of lubrication, then we covered how viscosity and coefficient of friction has been evolved, how various researchers have contributed. Then in the next lecture, we discussed what are various design parameters that affect the selection of various parameters for the bearing. And then in the next class, we discussed about the detailed design procedure which is being adopted for the selection of parameters of sliding coated bearing. I think these presentations will be useful for the readers and viewers. In the next class, I would discuss few numerical problems to facilitate better understanding of the concepts of the theory that we have undergone in the previous presentations. I hope you have enjoyed the presentation. Thank you so much for patient hearing.